Hello. Am I audible to all of you?
Yes. So,
Okay.
Hariom.
Hari. Yeah. Just 1 minute. Is my slides visible?
no, not yet.
No, not yet. Okay. Is it visible now?
Yes. Yes,
Yeah.
Dada.
Yeah. Okay. I will just run the slideshow. Just tell me, is it working? Is it working?
Yeah. Yeah.
Okay.
Yes.
Okay. Good. Thanks. Sorry for the delay. There was some technical
No,
issue
not
in my
no
Zoom.
problem.
Yeah.
Okay.
Okay. Let's start with a prayer. Yeah.
Yes.
या कुन्देन्दु तुषारहार धवला या शुभ्रवस्त्रावृता वीणाम्बरदण्डमण्डितकरा या श्वेतपद्मासना या ब्रह्माच्युतशङ्करप्रभृतिभिर्देवैः सदा वन्दिता सा मा पातु सरस्वती भगवती निःशेषजाड्यपहा. Welcome all for today's session. I think we had our last session. We covered about the Ekadikain Purvain circle of mathematics. We also covered the friend numbers, left to right techniques. Also, we have covered the completion and non-completion, and Yavadunam Sutra, that is by deficiency. Yeah. Yeah.
Yes.
So today we are going to revise some of those, and then we will proceed further for the next topics. Yeah. So left to right techniques, we have seen that we have to do additions from the left side. So 5 plus 3, 8, 7 plus 7, 14, 6 plus 8 is again 14, 8 plus 5 is 13. And then we do the adjustment in such a way that 13 we keep 3 as it is, 14 plus 1 is 15, so I write 15, keep the 5 as it is, move 1 next, so 14 plus 1 is 15, so keep the 5 as it is, move 1 next, so 8 plus 1 is 9. Yeah. So this is the way we should be doing the adjustment, because at one particular position there it is not possible to accommodate two numbers or the two digits in one place, because every position only contain one digit at a one place. So this is the left and right technique, always be faster, and it always be quicker from the carryover method, because there are no carryovers. So it is not a confusing thing for the students. Yeah. This is what we have covered in our last lecture. Is this particular method clear? How to do left to right and how to do carry, like move the digits? Yeah. Okay. Let's go to the next thing. We have also learned the all from 9 and last from 10. Means the formula is
Yes.
subtract all the numbers from 9 or the first numbers and only last number from the 10 to find the difference between the number and its highest base. So for example, 1000 minus 307. So So how to do that? Because there are 3 zeros, 3 numbers, so we can straight away apply the formula. So 9 minus 3 is 6, 9 minus 0 is 9, 10 minus 7 is 3. So answer is 693. So this way it makes much more easier, and the student don't have to use any carryover. Yeah? This is what we covered also in last lecture. Also, we have covered the numbers with a zero, number of zeros equal to the number of digits. Yeah, the number of digits, these are the thing. 892 means 3 zeros, 3 numbers. So we can straight away apply this technique. Yeah. Also, we have covered the adding leading zero. Okay, now we are going to focus on this one today. Yeah, adding the leading zero. Yeah, this is the second type we are going to learn. Suppose, yeah, my problem is that 1000 minus 43. Now 1000 has 3 zeros and 43 is having 2 digits only. So to adjust the number 43, I'm going to add a leading zero. Leading zero means at the beginning of the 43. Because if I add the trailing zero, means at the end of the zero, the value will be changed from 43 to 430. We don't want to do that. That's why we add the leading zero. It matches the number of digits then. So then we apply the formula. 9 minus 0 is 9. 9 minus 4 is 5. 10 minus 3 is 7. So answer is 957. For example, another problem, 10,000 minus 58. Now number of zeros are 4. Number of digits are 2. So we add 2 leading zeros. And then we say 9 minus 0 is 9, 9 minus 0 is 9, 9 minus 5 is 4, 10 minus 8 is 2.
It is 2.
Clear? Is this method clear? How to add the leading zero?
Yes.
Yeah, very simple, very easy to remember. Yeah. Next is that how to add the leading zero. Even we can do it without maybe going in a proper format. You can simply say 1000 minus 35 means add one leading zero. So 035. So 0 minus 9 is 9 minus 0 is 9. 9 minus 3 is 6. 10 minus 5 is 5. Okay, so that way you can find the answer, that is 965. Yeah, the third sum I'm referring to. Yeah, is this sum clear? 1000 minus 86. So again leading zero. 9 minus 0 is 9. 9 minus 8 is 1. 10 minus 6 is 4. 9 minus 0 is 9. 9 minus 9 is 0. 10 minus 3 is 7. So answer is 907. Is the leading zero problems clear? Yeah.
9 minus
See.
6. 9 minus 7.
Yeah. 9 minus 0 is 9. 9 minus 6 is 3. 9 minus 7 is 2. 10 minus 8 is 2.
Yes, correct.
Clear? Yeah. If you have pen and pencil, or if you have book, write it down so that it will be easier for you to remember. Yeah. Is it clear?
Yes.
Yeah. Should I move to the next question? Yeah.
Yes, sir.
Now, reducing the first digit by 1. See, when we go in a real life, it's not always possible that we are carrying 1000 or note, or say maybe 10,000 note or 100 note here. It could be we are having 500 rupees, or we could be having 5,000 rupees with us, and the bill is 243 or something like that. That is the problem. How to solve? See, the first digit is not 1, but number of zeros are matching. Yeah. So what the technique is, reduce the number 5 by 1. Okay, reduce the number 5 by 1. So make it 4. And then just apply the formula. 9 minus 2 is 7. 9 minus 4 is 5. 10 minus 3 is 7.
7.
Clear?
Okay.
Just reduce the first number by 1. Okay, so it's like that. Say if you have 5,000 and our bill is 243, so we keep the 4,000 aside. We only use 1,000, and out of that 1,000 we pay 243. Yeah. Similarly, if you have 60,000 and we have to subtract 58. Now it's a combination of adding leading 0 as well as the reducing by 1. So 6 I reduce by 1, that makes 5.
1, 5.
Yeah. And then 9
Yeah.
minus 0 is 9. 9 minus
9.
0 is 9. 9 minus 5 is 4. 10 minus 8 is 2.
2.
Clear? Is this problem clear to everyone?
Hmm.
Yeah. If anyone
Yes, sir.
has any doubt, just ask me immediately. Yeah. Okay. Let's move to the next type. Okay. So before is these two types clear? Adding leading 0 and reducing the first digit.
First digit by 1.
Yeah. Is this clear?
Yes, sir.
Yeah. Okay. Now, today we are going to talk about one Indian great mathematician. See, I just wanted to take you step by step to all the techniques and all the things so that everyone will be on the same page. Yeah. Today we are going to discuss about a great Indian mathematician called Sri Dharacharya. Okay, Sri Dharacharya was supposed like some people say that he was born in the state of Karnataka, and he was uh, very profound or very knowledgeable person in Sanskrit as well as Kannada. And some people say, historians say that he was born in Bengal as well. But okay, that's another point of discussion. But his he was born in like 870 to 930 AD. Okay, and he wrote a main text or the main grantha called Shatika. Shatika, there were 300 verses written by him. He was a very scholarly person. Also, he introduced the Patiganit. This is one of the another text or another grantha he has written in the 8th in that particular 9th century. He was the main inventor of the quadratic equations of a general form. How to solve this quadratic equation, that is ax square plus bx plus c equal to 0, where a is not equal to 0, how to solve with the formula that is the quadratic formula minus b plus or minus b square minus 4ac upon 2a. This is what we learn in our school days. But it was originally invented by the Sri Dharacharya in 9th century. He was a very profound mathematician. Also, in engineering or the higher standards, like higher mathematicians, we learn the problems of series. Okay, series and sequences. Okay, those who have done engineering must be aware of this. There are 3 subjects in engineering: M1, M2, M3, and this is one of the topic of the series and sequences. So series problems and how to solve the series problems was first introduced to the world by Sri Dharacharya. Yeah. Also, geometry, the geometry was very advanced in India from the ancient ages. Geometry is not like a recent investment, like recent invention. Geometry, including triangles, how to do the triangles, how to draw the triangles, how to draw the circles, how to even calculate the area of the part of the circle. Okay, means that is we call the sector. Okay, so how to calculate the area of that. Okay, and how to do that. Okay, that is was also the formulas and the techniques were given by Sri Dharacharya. The conics, or sorry, the cones. Okay, the ice cream cones or the shanku that we call it in Marathi language. The cones and the rectangles. Okay, how to calculate the areas of rectangles, how to calculate the areas of squares were also introduced by Sri Dharacharya in 9th century. So Indian mathematicians, like these discoveries are not made in Europe or not made in Greek or not made somewhere else and then it arrived in India. It's not the case. Those were all discovered within India, and then from India, then it went to the rest of the world. So India was very like scholar. The scholars in India are very much advanced, or they are, I call it a scientist, or the Rishis are nothing but the scientists of the modern eras. And they have discovered such formulas which is really applicable in not only their day-to-day life, but solving the complex problems as well. Think about equation in itself, the quadratic. So we can't imagine that in the 9th century itself, people were aware of the equations and how to take the variables, how to use those variables for any calculations, and then how to calculate the values of those variables. This is very interesting stuff. And not only they obviously they are not using that time the x and y and z as per the modern mathematics. They are using the letters, that is sh, ko, or Sanskrit Devanagari letters to solve their problems. Yeah. Uh,
Yeah.
Obviously, because all those English alphabets, I have just put it for our understanding to correlate them with the modern mathematics. And that's why it is very much important for us to learn all those ancient texts or ancient scripture, understand those techniques and understand those content of it, and then introduce it into the modern context in the schools as well as the in the community. But main interesting thing is that not only understand, learn those techniques, and maybe enhance those further for the future of the India. So that's why it is important, yeah, to learn and the study. Next thing I wanted to give this important thing, that see, if you think the as I told you in my first lecture, that the India is gifted the zeros as well as numbering system to the rest of the world. But the counting mechanism in India was so advanced that, like, this is one of the Sridharacharya's invention as well, that he gave the number name to each and every number. Okay, means number of zeros. Say if 1 is called 10 or 10 is called dasha. Okay, 1, 2 zeros on a 1, that we call 100 is shata. Okay, shastra, ayuta, laksha, prayuta, koti. Okay, arbud, abja, kharva, nikharva, mahapadma, shanku, jaladi, anta, madhya, parardha. Means up to 17 digits we were able to, 17 zeros on the top of 1 we were able to count. So think about what is the use of this: to count the number of gold coins, count the silver coins, count the number of items, count the number of soldiers, count the number of Akshoni Sainyas in Mahabharata war, for example. Yeah. So how they were counted, it was without a mathematics or without advanced counting techniques, it is not possible. Even it is surprised that in a modern era, means if you think in 9th century Europe, people were not even aware of the concept of million, billion, trillion. Okay, those were words were introduced very late in the English or Latin cycle. And if you compare that, even modern mathematics in 21st century, there is only 10 raised to 100. There is a word given called Gogol. If you search on a Wikipedia, you will find it out. There is no word given to 110, means 10 raised to 110. Okay, but there are Sanskrit shlokas in Ramayana. It was introduced by one of the mathematician in India in one of the university lecture, that in Ramayana, Valmiki Ramayana, there was shlok to count the numbers to 10 raised to 283. Means it's, I'm just giving the list up to 10 raised to 17. But people used to count up to 10 raised to 283. Means number of, how many number of zeros above 1 is the 283 zeros on the top of the 1. It's really mesmerizing that how many big numbers we used to not only count but having a name for it as well. So that's why we used to call that, why India is like golden sparrow, because obviously there are not only lots of gold but also rich in vidya, rich in knowledge. and reach in technique to count the numbers. And those countings are required, obviously. If you read the Bhaskaracharya's books, okay, obviously I will discuss about that as well. There are counting mechanism from or weighing mechanism from a small sesame seed, means how to weigh the parmanu, how to weigh the anu till the highest number of counting mechanism, that is there is a word, and how to weigh the largest item as well. There are techniques in India that means from the smallest part to the highest part. If you see the concept or read the Upanishads, there are so many shlokas which talk about sukshma. Okay, means what they say that indriyas are visible to the eyes, but man means the mind is not visible to within our body, because it is sukshma. It or sukshma means it is very smaller than the
Yeah.
the buddhi is also sukshma or more sukshma or than the mana, means buddhi is very sukshma. Atma means there is what is sukshma than buddhi. There is that is called a mahat. And then what is sukshma than mahat is the avyakta. Avyakta is the more sukshma than the thing. And what is atma? Atma is much more sukshma than avyakta. That was the slok in a Kathopanishad as mantras. So even if you think in the context, okay, means even in the Upanishadic era, very like 4,000, 5,000 years back, people used to think the sukshmati sukshma thing, means up to the Kanad was talking about Parmanu and Anu in our literature. So people were thinking about the smallest of the smallest to the biggest of the biggest. Yeah, means 10 raised to 283. That was the reference found in Ramayana. So our ancient Indian culture was very enriched. There were lots of like scientific discoveries are currently happening across the rest of the world. Unfortunately, very few Indian universities are dedicated to do this such kind of research. But one need to understand that our Indian culture was very much enriched. And instead of using the words like a billion, million, trillion, we should be using the words henceforth like Koti, Arbud, Abja, Kharva, Nikharva, Padma, Mahapadma in our day to day life. Because that is our tradition, and those are coming from Sanskrit and which has a proper meaning to it, to each and every letter. Only thing, the common people are not aware of what is that. Okay, maybe people are aware of up to Koti. Okay, but very few people are aware of Sahasra, Laksha, Koti. But very few people are aware of Ayuta, Prayuta, Arbuda, Kharva. Maybe some people are aware of Kharva, Nikharva. But Shanku, Jaladhi, Anta, Madhya, Parardha. One should be using these names because those are derived from a Sanskrit. And the most beautiful part of it that there are shlokas also given how to remember that. Means when in Gurukulas they used to teach to the student how you should remember the numbering system. They were remembering them using the Sanskrit shloka. So because obviously there was no like a written student don't used to go with a slate and a pencil and pen. Okay, they used to like recite everything. So for even for mathematics, they used to recite with the help of shloka. So this is the shloka which clearly elaborate on how to remember the various numbers up to the stananam, means sankhya stananam vyavarartha kruta purve, means depending on the position of the numbers, how they should be used in the vyavahara. Vyavahara means in a day-to-day life. Okay, and how they should be remembered. Okay, see the beauty of it. You see the beauty of the Sanskrit shloka. So I feel that Sanskrit is a very important language, and every student should learn that language and see the beauty of it. Yeah. Is this clear? What I'm trying to say here? Yeah.
Yes.
Yeah. Let's let's go and talk about the one of the Sanskrit again Subhashit I prefer. Satyanusarini Lakshmi Kirti Staganusarini Abhyasasarini Vidya Buddhi Karmanusarini. What it means? The goddess Lakshmi always follows the truth. Okay, obviously, truth means Satya. Satya is the name of the Parameshwara. Okay, so Satya is a Vishnu, and that's why the goddess Lakshmi follows the Vishnu. Okay, so Lakshmi even in real life as well. So what the Subhashitkar trying to say that one should earn the Lakshmi with the help of Satya, means in a dharma acharana, you should be earning the money. Okay, you should follow the fame. Who follow, like fame is followed by the giving up. Okay, renunciation means giving up. Once those who give up, the fame follows them. Okay, one should not follow the fame, but let the fame follow you. One should not follow the Lakshmi, let Lakshmi follow you. Okay, and so to do that, the knowledge, okay, always follows the conduct. So once you improve on your conduct, you will get a knowledge. There is also saying that you should be obedient to learn the knowledge or to learn the vidya from a guru. And intelligence always follow the actions. Okay, intelligence, buddhi. Okay, buddhi is, I have elaborated the concept of buddhi as well in one of my articles. But buddhi is the, as I just said earlier, buddhi is a sukshmati sukshma than mana. Okay, but buddhi controls the mind. Okay, buddhi is a sarthi of a indriya ratha. So one should follow the actions to do that. Yeah. So just wanted to give you some additional information about today. But my today's focus of the lecture was to tell you the techniques of these two, that is adding the leading zeros and how to do that, and how to use the all from 9 and last from 10. In the next lectures, we are going to learn the next few techniques about this all from 9 and last from 10, so that it will be easier for all of you to see the various implementation methods of the same sutra for the various things. Because this sutra is all from 9 last from 10 is very important sutra, because it has profound implications as well as usage as we progress in our mathematics. So not only for the Vedic mathematics, but for the general other Indian or Bharatiya mathematics as well, this is useful. So one should be master in those sutras. Yeah, those sutras are like learning the techniques how to like astras. Okay, once you know the astra and how to use it, then it will be easier to conquer any war. So similarly, once you get the mastery on the sutras in Vedic mathematics or Indian sutras, then it will be easier to solve any mathematical problems. So it's not only the basic mathematical problems, it will be easier to solve, but as we go along, we will learn how to do the advanced mathematical problems as well. Yeah. So I hope it is clear what I wanted to get across in today's lecture. We have a few minutes, I think, left. So if you have any questions, we will discuss those. Yeah. Otherwise, I will send you all those videos and all. I'm just taking small chunk of things in one lecture because of the restriction of the 40 minutes, and so that I can give ample time for the discussion. And, yeah. Is this clear? Is this techniques clear? Reducing the first digit and adding the leading zeros, and how to do that, and all from 9 last from 10. Yeah. So as I go along, I will definitely increase the number of topics, but just wanted to not to rush in immediately to cover many things, but just to ensure that everyone understand, because we have a diverse set of students, like from smaller kids to the big people, adults as well. So ensuring that everyone will be understanding what I am trying to teach. Is this clear today, what we have learned?
Yes, it's all clear.
All clear? Yes. Any doubts? If you have any doubts, feel free to ask. Yeah, sorry, we have only.
Thank you.
Yeah. I will
Sir,
post
would you mind reading out the sloka of the numbers?
Sloka, okay. Yeah. Just one. Is this visible?
Yeah.
Yeah. एकदश शत सहस्रायुत लक्ष प्रयुत कोट्य क्रमशः. Okay. अर्बुदमब्ज खर्व निखर्व महापद्म शंकवत तस्मात् जलधिश्चान्त मध्यम परार्धमिति दशगुणोत्तरः संज्ञाः संख्याया स्थानानां व्यवहारार्थं कुरुत्वा पूर्वे. Yeah.
Thank you.
Yeah. So it's also, see, all the Sanskrit shlokas are rhythmic as well. So it should be like, if you read it in a rhythm as well, it is easier to recite. Yeah. Is this clear? Yeah.
Yes, sir. Thank you.
Any other questions if you have? Feel free to ask. Yeah. Okay. Or I will give you, I will send all the exercises as well from this today's lecture, because it is important to keep on practicing that. Because I have seen in my other class in Marathi that people are progressing well in the, like we are at 7 or 8 lecture now, and they forgot the whole thing. So it is very important that you should keep on practicing from the day one. It won't take, like, I'm not a fond of giving too much of homework, but still I would suggest to do, even it won't take more than 10-15 minutes to do your homework. If you do it, it will be really useful for the as we progress, because as we progress, number of techniques and number of complexity is going to increase. So better to build a foundation very strong from the beginning itself. Yeah. So I have just one suggestion from my other class as well. Keep on practicing. Yeah.
Sir, I have one question. Sorry, sir.
Yeah, go ahead.
Yeah, actually, I read it somewhere that Vedic mathematics should be taught to kids who are maybe more than 12 or 13 years old. It is not for the kids of younger age. So is it true or no? I mean, this is the question.
No, it is not true. See, it should be taught to anyone who understands the basic numbers and basic arithmetic things. See, Vedic mathematics is it's an ocean of knowledge. Ocean of
Right.
knowledge. It is not only for the kids, but even for the advanced engineering level mathematics. Because some of the sutras, like say Urdhva Gyam or even Nikhilam Navat, is used for the advanced geometrical calculations as
Right.
well in the very higher level mathematics. So
Yes. Yeah.
depending on the age, we can only teach what is relevant to their age. Yeah, means say
Right.
suppose, and then maybe as they progress, we can teach them as along. But the message I wanted to get is, sooner you start learning, better. Yeah.
Okay. Actually, I was just comparing abacus with Vedic mathematics, and they
Yeah.
were saying abacus can be taught to kids who are just 6-7 years old, but in case of Vedic mathematics, we need
No,
to wait.
it's a wrong perception. Like like I have taught to many smaller kids even. Means
Right.
even just like I have one student just from a first standard or even KG. I just taught him numbers. I taught him how to do addition, and at that even small age he learned fast.
Okay.
So it's not like age is not the restriction for learning. And what is my suggestion to start early? Reason is because that age their brain is very active to learn. Okay, and they learn it very quickly. Means as I mentioned in my first lecture, there was a scientific neurological experiment conducted in Venice. They taught 12 languages, 12 world languages to the 12-year, like up to 12-year. He was taught from the very small age, like 4 and 5. Up to 12 age, he could become a master on 12 languages, not only grammar, not only language, reading, writing. He was fluent on all 12 languages. So age should not be a restriction to learn. Yeah.
Okay, thank you.
Means smaller or even if you grow old, you should learn. That's what I'm trying to say.
Yeah.
Sir, regarding last week's homework,
Yeah.
I have done it, but I would like to see whether I have done the correct method. So will you be
Yeah.
showing the process or that
Yeah.
like how you
So
change the
what you can do, you can message me separately. You can just put a photocopy of or the page of your photo. I will check it immediately, and if you have anything done wrong methodologically, I will immediately explain it to you. Yeah.
Okay. I'll
Yeah.
do that. I'll do that because
Yeah.
I've just done it. I'm not very sure.
Yeah. So if you have
whether
anything in any doubt, you can ask me anytime. So do you have any problem that you wanted to talk now? I can explain you immediately.
No,
sir,
because,
hello,
Sorry.
hello, carry on.
No,
no, you carry on.
Go ahead.
No, you carry on. Sorry.
Yeah.
Sir,
No.
the type 3, reducing first digit by 1. That is, suppose if it is a 5,000 now minus 243. So we are, this is the type 2, adding a
Leading zero.
that leading 0. That 1,000 by minus 86. We are this thing, minusing first by 9 and the last by 10.
10.
Suppose if the last, instead of 86, if it is 80, 1,000 minus.
So 80,
So
see, there are two things for the suppose I take an example, 100 minus 80.
Yeah.
Yeah. So
Yeah.
in that context, there are two ways to do it. Yeah. First is apply the same thing. 9 minus 8 is 1. Yeah. 10 minus 0 is 10.
Yes.
Yeah. But
Yeah.
at unit place, you cannot have two digits.
Yes.
Yeah. So you move 1 to the left side.
That becomes 2.
Yeah. So it becomes 2 and it becomes 0. So keep the 0 as it is, move 1 to the next position. So it becomes 2. So answer is 20. This is one way.
Oh.
Yeah. Another way
Okay.
is that keep the 0 as it is. Second method to that is suppose 80, keep the 0 as it is.
9 minus 8.
And no, keep the 0 as it is and treat
Okay.
8 as a last digit, because obviously there is no further digit. So this becomes a last.
Yeah.
No,
Yeah.
I didn't understand the second time.
Okay. Second time. Okay. Number is 80.
Yes.
Okay. So keep the 0 as it is. Ignore the last 0. Yeah. Keep it as it is.
Okay. Okay.
So out of 80, 0 is gone. So what is remaining?
Yes.
8.
The 10 minus.
So 10 minus 8. That's it.
Yeah.
So by ignoring 0, we can do that, or we can simply follow the same technique.
Oh,
Is
I
this
think
clear?
first technique.
Yeah. So just stick to one technique, like all from 9, last from 10, and do the adjustment. That's it. Yeah. It's up to you. I mean, see, there are various ways to solve the same problem, but I'm just explaining you both the ways.
Yes. No, if it is a 2 digit, 2 zeros is okay. But if there are 4 and 5 zeros and only the 2-digit number we have to minus.
Yeah. Suppose.
Better,
Okay. Let us take this example.
the first.
10,000 minus 800. Yeah.
Yeah.
Is my screen visible?
Yes.
Yes.
Yeah. So number is 10,000 minus 800. Yeah.
Yes.
So obviously there are 4 zeros, 3 numbers. So I add a leading 0.
Yes.
Okay. Then I apply the formula. Yeah. 9 minus 0. 9 minus 0. Tell me.
9.
9. 9 minus 8.
1.